Hi, welcome back to our next level 3 integration video and our second video on the integration by substitution technique. Right, straight into our example. There's only one in this video. So example 1, we're going to integrate 2x over the square root of x plus 3 with respect to x. Now the technique we're trying to learn, called integration by substitution, is a technique where we replace all the x's with u's and integrate with respect to u, because it's trying to make the problem easier, and in this process we're able to do that a lot easier when we do this. So let's show you what trick we're going to do in this problem. We're going to start off and let u equal to x plus 3. While we're here, we're going to differentiate the u function with respect to x and get 1, because 1x differentiates to 1 and the plus 3 differentiates to 0 and disappears. Now, because du is over dx is 1, we can say du is equal to dx. Any number that's du has to be the same as dx, because any number divided by itself is 1. So du is equal to dx. That's great. That's a little easier than the problems we had in the last video. All right, so we're going to write this down. We're going to integrate 2x, that's left on the top, and on the bottom we're going to take the square root of u, and we're going to put du. So we're going to put x plus 3 and replace that with u, and because du and dx are equal, we can just swap over du and dx. All right, well now the problem is we've got still an x on the top, so we've got to get rid of that x. We're trying to get everything away. So here's what we're going to do next. We're going to go u equal to x plus 3. We knew that, but let's rearrange that to get u minus 3, because we take that plus 3 and put it on the other side to make it a minus 3, is equal to x. So here's what we're going to write down next. We're going to integrate 2 bracket u minus 3 on the top. And that's because we've taken this u minus 3, which is x, and substituted it in for u minus 3 for that x. Finally, we've got an expression that's got everything to do with u's. And we're going to integrate this function with respect to u now. Has it made it easier, and can we do it? And the answer is yes, we can. So let's work through the rest, see how you follow. First of all, let's expand out the brackets. 2 times u is 2u. 2 times minus 3 is minus 6. Now, because we have one term on the bottom, let's split it up into this fraction of 2u over square root of u minus 6 over the square root of u. We know the square root of u can be written as u to the power of a half. Right, we're going to go over here and do our working here. So now what's gone on here? We have 2u over u to the power of a half. The 2 stays there, but the u over u to the half simplifies down to u to the half, because we go u to the power of 1, subtract u to the power of a half. And for this part, we're going to bring the u to the power of a half up to the top of the fraction and join on with the minus 6, and it's going to become a negative half power. Right, well finally we're ready to integrate. After all that working, we can do our integration. So let's add 1 to the power and divide by the new power. So we add 1 to the power of a half to get 3 halves and divide by the new power of 3 halves. We add 1 to the power of negative a half to get a half and divide by the power of a half. Right, remember the dividing by 3 halves is swapping around and timesing by 2/3, so the 2 joins up, and so does the half on the other side. Dividing by half joins up with the 6, so we end up with 4/3 for the first fraction and 12 over 1 for the second fraction. Finally, we can go back and replace u's with the x plus 3, and write our final answer down as 4 bracket x plus 3 to the power of 3 halves, divide 3 minus 12 times x plus 3 to the power of a half plus our constant c. And if you want to tidy that up in exponent surd form, you'd simplify it down to this. Right, thank you very much for watching.